Wait, so I found all these shapes. Okay, let's start with fire and tetrahedron, okay? So it has 4 zeroth dimensional singularities, 6 one-dimensional edges, 4 two-dimensional faces. Okay, well you are looking at the tetrahedron, okay? And I will show you all little bits. You have 1, 2, 3, 4 zeroth dimensional singularities, or vertices. You have 1, 2, 3. We created this one, 4. And then this one over here also goes 5, 6. And how many faces do you have? You have 1 face, 2 face, 3 face, and the bottom side, 4 faces. Just to be clear though, like this line is going to want to come into this dot, and this line is going to want to come into this dot. And the same with this line is going to want to, join up with everything to make an equilateral tetrahedron, but it's on a tilt and it's depicted this way, okay? Do you look at the fire? So before we get to the next stuff, let's just go over the 9 shapes that there are. There are 9 two-dimensional pictures on here, okay? You have this orange diamond, you have this sideways club, you have your spade down here and your heart over here. Those are your 4 suits in your deck of cards. You have the Superman logo up here, okay, or the more fancy diamond for 5. You have the S for Superman, or a dollar sign, or your 1, 5, 7, 8, 4, 2 for vortex math for 6. You also have the stem and the leaves of the flower for 7. You have the daisy here for 8. And you have a hypercube for 9. 9 things. Agent 999. Okay, the Earth is a cube, okay, has, 6 faces, 8 vertices, 12 edges. We all know what a cube looks like, okay? And that's over here, and that's the hypercube. Okay, so what we got is this little square within a bigger square within a bigger square. Okay, you have a 1 by 2, a 1 by 3, and a 1 by 4 doing stuff. So what I see is I see a window, okay, a 2-dimensional plane, where you see 3-dimensional objects, if you were to align them, you know what I'm saying? Like a square and a square. Square in the background, a square in the foreground, line up the corners, cube. So 3-dimensional objects in a 2-dimensional plane. Or how about this? Let's just take away everything and see 1, 2, 3, 4, 5. Oh, okay. Because 3 makes 1, 2, 3, 4 when you account for the 0th dimensional singularity. Makes 1, 2, 3, 4, 5. 3, or 1, 2, 3 makes 4, makes 5. Because when you understand the right hand of God, it folds over the rainbow bridge to the left hand. And usually it's about energy and stuff. Alright, so that's the cube. 5D Earth. 3 makes 4, makes 5. Alright, in this quadrant we're going from this giant sideways 3-leaf clover to this very pretty 4-leaf clover. It's about light and the visual light spectrum. The infrared 4 wavelengths and the, or whatever, the, I always say it backwards. The ultraviolet 4 wavelengths and the infrared 3 wavelengths or whatever. It's really late, I'm tired, okay? So 3 and a 4, okay? Now, it represents the air, because light is in air, okay? And you have 6 0-dimensional vertices. Okay, let's start with that. So what do we got here for 6? 6 0-dimensional vertices. Let's just go with a 1, 2, 3, 4, and then we have a 0 and a 0 for 5, 6. Alright, we have 1-dimensional edges. We have 12. Oh yeah, this one was funny. Okay, so we got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, and we got 8 two-dimensional faces. Well, 1, 2, 3, 4, 5, 6, 7, 8. Alright, that's done. So, yeah, lucky 4-leaf clover, unlucky 3-leaf clover. So that's basically the the octahedron. So Left is these two. So spirit is a dodecahedron, okay? It has 20 vertices. Let's just start with 20 vertices. So the dodecahedron, I'm going to call down here, okay? It's this, basically this window, okay? And it's also the stem and everything in there, okay? So it's literally like a 9 by 9, okay, in a window, okay? And the window here doesn't include this because this is part of a black hole or whatever, so we don't include that. It's only these guys. So 20 vertices. 4 times 5, 20 vertices. All right, done. 31 dimensional edges. All right, this one's fun. So essentially you have a 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. You have 16 lines in here. You're making a little square, 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 square. 16, right? 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31 dimensional lines. And we have 12 two-dimensional faces. 12 two-dimensional faces. Okay, so like how many of those do you have? 1, 2, 3, 4, 5, 6, 7. Oh wait, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, you have 12 fours. Alright, so that's your spirit, that's your dodecahedron. Okay, so we have like, you know, tetrahedron, cube, octahedron, dodecahedron. And now we're going to finish with icosahedron, or water. Okay, it has 12 vertices. Now we're on to water. Okay, water has, like 20 faces, and an dodecahedron has 20 vertices. Now, if the vertice of a dodecahedron is in the middle of the face of an icosahedron, well, that works. Okay, so that means that the same methodology we calculated 20 here, we're going to do the same thing over here. And that's a 4 by 5, that's 20 cells. So that's your 20 faces. So it's a different way of looking at it. Now, your 12 zeroth dimension vertices. Alright, your 12 vertices. Where are they going to be? Well, they're going to be yeah. So this 4 will be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because remember, these are all waterfalls. They're all just dots. Okay, so those are your 12 vertices. They're going to be like a 2 by 2 dot. And your faces are going to be the literal selves of the cells themselves. And you have 30 edges. Okay, well, it's going to be the same thing we did on this side. Okay, on this side, what we did was we counted a 4, 4, 4, 4 for 16, and then we counted all the way around. Right? So let's do that the same over here. So 4, 4, 4, 4, 16. And then we have 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So icosahedron, dodecahedron, octahedron, cube, tetrahedron.